Next we have Josh Simons from VMware, and he's with the Office of the CTO and focuses on high-performance computing. So given what we just heard from Wim, I think this is a great segue into the virtualization angle. So let me get it up here and we'll get going. That should work if you want this one, or you can have this one, either way.
Thanks very much. So I'm going to talk today about some converging concerns between HPC, the cloud, and enterprise. Before I do that, let me give you sort of a rundown of how I want to do the talk. I want to first talk about what I'm doing at VMware and use that to motivate a discussion about some larger trends that we see. And then I'll move into talking about RDMA specifically. Now, before I go to the next slide, I do want to say that I've been at VMware about a year now. My background is all in high-performance computing. I spent about 14 years at Sun doing HPC, and before that about 9 years at Thinking Machines. So that's my community. The whole enterprise side of things is actually quite new to me. Having said that, I also want to mention that because there are so many high-end HPC people in the room, my definition of HPC is essentially the analyst definition of HPC. So it's much broader than just the high end. It encompasses things like financial services and high-throughput computing and things like that. So what I'm working on actually is looking at uses of virtualization for HPC. First, I want to run through quickly the use cases some of the use cases that we see for using virtualization in an HPC environment. I won't have time to talk about performance, which I'm sure a lot of you would be interested in hearing about, but we can talk about that offline. The short version of that is that node level performance actually looks pretty good with all the improvements in software and hardware that have gone on over the last several years. The issues are around I/O, and we'll talk about that when we get to RDMA. And then the other thing I'll say before I continue is RDMA for me is shorthand for high bandwidth, low latency, CPU offload. I mean, RDMA is actually a statement of a solution, not a statement of requirements. Those are my requirements. Okay, so virtualization. Just by way of background, because I don't assume that all of you have a good understanding of what's going on in the enterprise world. Virtualization is primarily used in the enterprise for massive consolidations. That's removing large numbers of physical boxes from your data center and replacing it with a much smaller number of boxes and then running a very large number of virtual machines, typically, on that hardware. The HPC use case here would not be to oversubscribe the hardware resources. I'll show you what those use cases are, but it would be to run a relatively modest number of virtual machines on your hardware without oversubscription of the CPU or memory. But this is the way it works in the enterprise environment. Another component, or I guess a primitive capability in the virtualized environment, is this ability to do snapshots. It's leveraging this very clean interface between the hypervisor. VMware's hypervisor is called ESX. You'll see that on some of the slides. Leveraging that clean interface between the hypervisor and the virtual machine abstraction to be able to do essentially checkpoints of full OS instances. I'll show you how in a few minutes we could use that in an HPC setting. And then the last one, and Wim just mentioned this, is live migration, the ability to move workload while it's running from one physical machine to another. So shifting a running OS instance from one box to another. There's a slight pause in the middle as it's moved over, but essentially you're paging the memory over between machines. You're doing that in multiple rounds, and once you get to a small enough working set of dirty pages, you then pause the machines and then move the rest of the virtual address space and then continue the VM. So those are primitives that are available within a virtualized environment. So the question is, in an HPC environment, how would you actually take advantage of this? So clearly, and this is one of maybe two main drivers that have HPC folks looking at using virtualization for HPC. One is sort of as an on-ramp to the cloud. It's really table stakes. If you want to go and use the clouds that exist today, you need to be able to run your HPC workload in a cloud environment, which brings a lot of customers to us asking about how well their applications will actually run there. Another point, and this is perhaps obvious thinking about the snapshots, is the ability to leverage that snapshot capability to do checkpoint restart of HPC apps. Now, not teasing the state of a process out of a running OS instance, but checkpointing entire OS instances. And you could imagine using this for MPI jobs. So you would checkpoint a set of running VM instances on your cluster and then restore from that. Now, there are several things you can do with that live migration capability, which we call vMotion at VMware. Proactive fault tolerance is something, and this is by way of vision, by the way. This is not something that we do now. Proactive fault tolerance is the idea of using underlying telemetry within your machine to predict upcoming or potential failures in hardware or underlying software, and actually using the live migration capability to move the application and its VM from one machine to another before the failure occurs. So essentially dodging the bullet. And you could imagine extending this to work in an MPI environment as well. Obviously, there are complexities around dealing with the connections coming into and going out of that particular MPI rank, but the idea is the same. And this has been something has, at least in the discussions I've had with Trilabs people, is something that catches their attention, because clearly going to exascale, there's going to have to be a lot of work around application resiliency, algorithmic work, and system level work as well. So this may offer a capability that could be useful in that realm. It's also a nice way of doing dynamic resource management. On bare metal HPC clusters now, when you place your when you place your jobs onto a cluster, they stay there until they either finish, or you kill them, or they complete. With the ability to use live migration, you could actually move workload around to make room for, say, a higher priority job that comes in after you've done your workload placement. You could also use this for power management. So in situations where you're not running 24/7, using all of your resources, the ability to essentially move that workload onto a subset of your resources is a way of potentially saving some power. And another that turns out to resonate fairly well with a lot of customers is this idea of moving from what we'd call a bare metal cluster that's running a single prescribed operating system distro across many, many nodes, say in a shared resource, to a virtualized environment where individual research groups or scientists or whoever are able to make their own decision about what kind of software stack they need to support their particular application. So a shared resource site that wants to support, say, SUSE and Red Hat and Solaris and you name it, say Windows as well, moving into a virtual realm allows that to happen much more easily. And then there's something I'm sort of lumping into a group called clean computing. And this is the idea that by wrapping your application within these VM abstractions, there's several things that occur here. You get some security. So if you're running multiple instances of multiple jobs on the same physical box, by encapsulating them within these VM abstractions, you allow some level of security and isolation. It's also the case that if you're starting these applications within these VM environments, you know that they're going to be starting in a pristine state, so you're not worried about what LSF or Grid Engine or some other distributed resource manager left lying around on the system when your application is now scheduled to run on that node. Okay, so that's a brief overview of what I'm doing and the kind of value props we're looking at for HPC. Let me now move on to talk about this larger trend that I think is actually critically important for this community and for several other communities several other HPC related communities, let me say it that way. So historically, if you've looked at the stacks that are used in the enterprise and the stacks that are used in HPC environments, they've been pretty separate. And actually, I should say that these are not drawn to scale. This is probably much more accurate, right? So, and as I said, my home has been on Ganymede down there on the bottom for the last 20 years or so. So I'm with you totally. But if you think about this, where is the center of mass of the system, right? It's not anywhere near Ganymede, right? So the point here is that it's really important to find shared concerns between these two communities, and it turns out there actually are a pretty interesting set, and this is just some of the places where there's overlap. There are places where there are these shared concerns. The benefit to the HPC community in leveraging these shared concerns is obviously anytime we can find something that's of interest to us and we can get the large planetoid to be interested in that, the IT vendors, VMware and all the hardware vendors as well, will be much more interested in satisfying those requirements because we follow the money, frankly. So I'm not going to go through all of these, but you can read them, so I'll call out a few just to give some color to this. Scale-out management, that has been the sort of hallmark of the HPC community for a really long time, but look at Google, look at Facebook, look at all the big web properties now. We are not on the leading edge necessarily within the HPC community anymore around size of data center and size of deployment. We may use ours in a different way, but scale-out is not just an HPC issue. Power and cooling has become a ubiquitous problem across the entire space. Dynamic resource management, there are problems sorry, not problems, but points of contact, I'd say, up and down the stack, up to parallelization as well, for example. You'll see that low latency interconnect is on here as well, and that's really the next thing that I want to talk about. And actually, before I get to that, this is a particularly important space for us to be thinking about. This is another area of overlap. It really is same problems, different labels. This whole idea of big data analytics is becoming really, really important on the enterprise side. It's getting a lot of attention from people, and by the same token, we have data-intensive computing emerging within the HPC space as an interesting sort of sub-discipline that has a very different kind of problem than the typical sort of physics simulations problems that we're solving. And there's a large amount of commonality here in the algorithmic approaches and the sort of problem types that need to be solved. I like social networks as an example, right? So Facebook is doing mining of these absolutely enormous social networks, and Homeland Security wants to do mining of sort of anti-social networks, right? The same kind of algorithms. Okay, so RDMA. For us, there are two concerns here, right? So we're a virtualization company. I guess I didn't say that at the beginning. I assume you kind of know what we do. So there's the guest OS level and what's visible to the guest operating system and to the application that's running in that operating system instance. But then there's also the virtual infrastructure. And a lot of times when we talk about virtualization, we talk about the hypervisor. That's obviously one central component in the virtual infrastructure. But really, you need to think about the virtual infrastructure as being essentially a virtualized data center. There's virtual networking, virtual security appliances, virtual storage. It's really actually quite a sophisticated set of software that develops or presents an entire virtualized platform. So both of these levels are places that we would look for RDMA, potentially, look at the value. So harking back to what I said earlier about finding touch points. So my job within VMware is to promote HPC, certainly externally, but also to promote it internally as something that the company should be looking at. So rather than having internal discussions with people about why something is important for HPC, I need to find ways I can tell them why it's important for the enterprise side of the business. And then HPC can get pulled along, essentially. So it turns out within our virtual infrastructure, there are several places where high bandwidth, low latency, and CPU offload actually could play a critically important role in improving the virtual infrastructure. So vMotion, our live migration capability, and I'll show you a slide on that in a minute just to give some more color to that. We also, and I won't talk much about either of these, but it's very interesting to us to think about essentially real-time state mirroring between virtual machines on different boxes. And you could easily imagine how an RDMA capability would be useful there. Shared storage access is also an important issue for us, and being able to deliver high bandwidth and low latency there can certainly add value. And then distributed file systems where you aren't necessarily accessing a single large SAN device, for example, but you're accessing well, I don't want to say much about it, but some kind of a distributed file system would clearly benefit from this sort of approach. So in terms of RDMA, I just love the paper that DK Panda and his team did about use of RDMA for virtual machine migration. It just sort of nails the case. It shows you very definitively how this kind of a technology can be of benefit to something that really isn't something that the HPC community looks at all. So this is gold for me. I can take this and I can go talk to management. I can show it to them, and make some real headway. Mellanox also did some nice testing. They showed on the bottom left that if you go from 10 gig to 40 gig, then you can decrease the amount of time doing your migration, which makes sense. The more interesting one is on the right, where they're actually migrating a running VM. And the reason they get a better performance boost there is that if you are faster at moving the data, then the VM that's running has less time to actually dirty memory. And so you end up transferring less data in the process of doing the migration, which is pretty cool. So again, this kind of a proof point really helps me a lot. Okay, on the guest side, things get a little bit more funky for us. And this echoes some of the things that we heard in the Oracle talk. So it's very clear that bandwidth and latency are becoming increasingly important for enterprise applications. Scaleout middleware is becoming much more common. And you heard some of these from that are listed here from the Google talk on our first evening, Memcache, Cassandra. I added a few other, MongoDB. They're all some flavor of distributed, typically in-memory data cache or file system. Gemfire Data Fabric is a particularly interesting one for me. This was, it's a product done by a company called Gemstone, which VMware acquired a year or so ago. The reason I'm interested in that is because when they run that in a virtual environment, it doesn't run very well. It has some pretty serious performance problems. And we've done some tuning. It turns out it is a latency problem. So some kind of latency relief, perhaps an RDMA solution, would be of benefit. Again, this lets me go back to management, and I'm going to keep harping on this and say, look, we can fix Gemfire, we can fix all, we can add value on the platform by actually integrating these capabilities. Big data, as I mentioned earlier, is a really important emerging space within enterprise. Hadoop, Hive, Pig, those all play there and would also benefit. And clearly HPC. And it's perhaps maybe not known, but we have a lot of VMware customers that have real HPC workloads. And you'd recognize them. They're in EDA, they're finance, digital content creation. They're in a variety of verticals. Actually, some of the labs are some of the tri-labs are some of our customers as well. Okay, so how might we do guest RDMA? There are kind of three ways we could look at this. So we have something called VMware Direct Path I/O that basically allows us to take a piece of hardware and punch it through the abstraction and make it directly visible to the guest. As was mentioned earlier, that is a way of getting performance from that hardware, but it kills vMotion or migration. And for us, as for Oracle, that is not acceptable. We absolutely need a way to maintain the ability to migrate that workload. It's a core capability within the virtualization realm. So another thing we might look at doing is something that we call mediated pass-through, where you do the same punch-through, but now you have some kind of a call-out to say a middleware layer, and you cooperatively do a state save. So the easiest way to explain that would be to think about, say, a GPU sitting in a box that you're running a virtual machine on. What you would do is, when you're ready to do the migration, you would signal the GPU with an API, pull the state out of the GPU, do the migration, and then use the other half of that API to actually restore that state. So you're mediating the pass-through with this outside entity. You could imagine doing something like that for InfiniBand, say, or sorry, for RDMA. At the MPI layer, for example, that would be a convenient place to do it. It's not clear where we would do it in the general case. And in any case, we have a bigger sort of philosophical problem within the company about mediated pass-through, and that's that it's a dependency on an external layer. In an enterprise environment where it's so critical to have uptime, as was mentioned in the IBM talk, it's really a 24/7 environment. Having a dependency on some kind of layer that we don't have control of makes people very nervous at VMware. So the other thing we could do, and we're really just starting to think about this, is to actually construct a true virtual RDMA device. And what that actually would look like at this point, we don't know. And what kind of performance we would get from that, we don't know. It's just something that we're starting to look at. But what are our requirements? So we need to be able to do vMotion, and we need to be able to do not just vMotion, but we also need to be able to vMotion to a host that lacks RDMA hardware. So from one that has it to one that doesn't have it. And I realize that that's a difficult issue. Things like soft Rocky start to look really interesting. Hearing about the soft iWarp capability in the talk yesterday also caught my attention. That might be, either of those might be a way forward for us in that realm. I think it's important to have that kind of a capability. It's key for us in the enterprise, because we always have to have a place where we can migrate workload. We can't get ourselves stuck in a situation where we're constrained and we can't actually take an action. I think it's actually interesting and useful more generally, for example, in a cloud environment, or just generally for adoption of RDMA, because it allows you to deploy it incrementally into environment, as opposed to going to a 10,000 node cloud environment and saying that everything needs to be RDMA right off the bat. You can roll this out much more incrementally. We need multi-VM hardware access, so I could have written SRIOV there, but that's a solution, that's not the requirement. And the reason I didn't state it as SRIOV, for example, is that we currently share, for example, Ethernet devices in our virtual environment. We don't use SRIOV to do that. The virtualization infrastructure takes care of that sharing. So we have not implemented SRIOV at this point. We also need interoperability with physical endpoints, so we can't assume that it's virtual on both ends. And that's, I think it would be unreasonable to assume that file system servers are virtualized if they don't need to be virtualized. So that's important for us. Low latency is clearly one of the big points here, so we need that. A question for us is, how much of that latency would we be willing to give up to get some of these other capabilities? I think we actually, realistically, would be willing to give up something, which is not good news to the HPC community, especially the high end, but for a fairly wide range of within the HPC market, I think giving up some latency for these other capabilities would actually be quite acceptable. That's open to debate, but I believe that's true. Now, from an API perspective, verbs is clearly completely okay from an HPC perspective, but echoing some of the comments earlier, something nicer or easier to use for the enterprise. If you think about these enterprise distributed applications and frameworks, they're probably not going to code to verbs. I just don't think they would. So some kind of ultra-fast sockets, as was mentioned earlier, might be a better way forward there. Okay, final thoughts. So Moore's Law, multi-core, so the people that weren't here at the beginning, the dodo bird comment related to, I think it was Bill Daley made a comment about interrupts going the way of the dodo bird. I would love to see that happen. Interrupts are difficult to deal with in a virtual environment. They add what seems to be some inherent overhead, because we have to take a longer code path through the virtual machine monitor to service interrupts. So the idea of using some of the real estate on future sockets for specialized capabilities like progress engines for any kind of interconnect, to me is quite appealing, and it seems pretty reasonable. I think it's getting quite difficult to actually usefully use all of the compute capabilities on these many and multi-core systems. So I'd love to see some motion in that direction. To Lloyd's comment about kind of evolving the organization and broadening it to enterprise, I think it's actually quite difficult for organizations like this to address markets that are different than the ones that are represented by the people that are already members. And I say that I'm currently on the board of directors for OpenMP, and we're wrestling with a similar issue, where that is a set of abstractions that have been developed really solely for the HPC community, and a lot of the work there has been driven by the very real requirements of the high-end HPC community. But if we're going to broaden the appeal of that standard, the OpenMP standard, to say enterprises or just other programmers that aren't as capable as HPC programmers and give them access to multi-core parallelism, we need to be rethinking how we do that. And I think there's a similar issue here for open fabrics. And this comes to the sort of fit and finish issue that was mentioned this morning. I really can't emphasize enough how important that stuff is. It's really critically important for gaining that broader acceptance in the enterprise. And again, I think the value there is if you can gain the acceptance in the enterprise, then all sorts of interesting things start to happen in terms of funding and vendors paying much, much more attention in the space. Compelling OFED demos would be great. Non-HPC OFED demos would be really interesting. So going back to the RDMA paper by DK and his team, that's a great proof point. These would also be proof points. And I'm impatient for RDMA. I want to see it everywhere. Once it's everywhere, it's really easy for us because when we do virtual machine abstractions, we're absolutely required to essentially reflect that capability up into the guest OSs. So it just isn't getting here quick enough for me. So go Open Fabrics. Questions? Yeah.
Josh, you guys don't support InfiniBand, correct? Yeah.
So with Mellanox, we have some IB support at the VM kernel level. And that's mostly used for I/O consolidation. So we have another partner, Zego, that actually uses, they build on the work of Mellanox drivers, which are done in the community source development, and offer the ability to run multiple 10 gig and SAN connections consolidated over IB. So we do have that level. We do not support it right now in the guest.
Is that on the roadmap? Is it hard to do? Why is that?
It's not on the roadmap yet. A lot of the discussion here is around the complexities of doing it. How do we do it with migration? How do we do it with high performance? And it's not on the roadmap yet. Yes?
So the live migration you talked about, vMotion, is that currently available?
Yes. Yes, vMotion is it's actually widely used within the virtual infrastructure. Yeah. Yes.
Hey Josh, on the chart where you showed the 10 gig and the 40 gig performance, was that RDMA to RDMA 10 gig, 40 gig, or was it non-RDMA to RDMA?
Honestly, I think it was non-RDMA to non-RDMA. I think the first one on the left was just showing the bandwidth improvement.
Okay, got it.
Yeah. Yes.
You talked about moving application prior to the failure. How can you predict the failure?
Yeah, so the question for those that didn't hear it is, with this idea of moving VMs before a failure occurs, how do you actually predict the failure? Well, it's hard, right? So there are some things that are relatively easy. So if you're looking, for example, at the rate of, say, uncorrectable memory errors, and you think you want to take that as a sort of indicator that you might be heading into a more serious problem, that would be one case. But there actually is a fair amount of interesting research looking at telemetry streams coming off of hardware and doing fairly sophisticated statistical analyses of that telemetry stream to try to predict anomalous behavior on systems. And you could imagine bolting that kind of a capability onto the vMotion capability. Any other questions? Oh, yes?
SROV and VMware support, is that any kind of commitments to deliver it?
Yes. Right. So the question is SRIOV support committed from VMware? I don't believe it is. And again, it's for the reason that I mentioned earlier. It's that we already do the moral equivalent within the virtual infrastructure. But having said that, if we're going to do something like punching, say, an InfiniBand card through into a guest, we kind of need it. So that's on my list. Yeah.
You said moral equivalent. What it is exactly?
Well, it's all done in software, right? So we have the ability to steer multiple flows through an individual piece of hardware, but we do it all with the virtual networking infrastructure that we have as part of the overall virtual infrastructure.
Are you talking about NIMT?
I'm sorry?
You're talking about NIMT I/O control?
Among other things, yes, that's right. Any other questions? Okay, thank you.
Thanks, Josh.